Okay, cool. So welcome everybody to the third installment of our discussion of R for DS. Today we're going to be talking about we're going to finish up take 10, maybe 15 minutes, just finishing up the data visualization chapter. I'll be covering that. And then I'm going to transition over to Dewey, who has graciously said he will lead our discussion of chapter 2, workflow basics. And so really appreciate seeing everybody here today, and I kind of want to just get started here, really. So let's see. Let me share my screen here. Desktop one, share. Okay, can everybody see my slides? Excellent, great. Looks like we're getting a little bit smaller of a group, so that's good. Hopefully we get some more people to kind of join in a little bit later on. So if I was using the chat before because we were such a larger group, but because we're starting to become a smaller group, it's you're more than welcome to unmute yourself, jump in at any time. So don't feel like you need to use the chat. You can if you want to, but because we're starting to become a little bit smaller of a group, leaner group, if you feel like you want to jump in and add some stuff, don't be afraid to do so. I think that's where we get a lot of benefit is from just like discussing things. So I'm going to go through the last part of chapter one, data visualization. It's really going to go really quickly. But basically where we left off was this discussion about visualizing relationships or visualizing variable relationships within our data. ggplot is really good at it. I don't think we need to talk more about that, but basically when it comes down to this, it depends on what type of variable relationships you're looking at. Usually when you do this, you're going to specify everything in your aesthetics. So what variables you want to look at or what relationship you want to look at. But then you're going to use a geom to tell, okay, what geometry or what shape do you want your data to take? And what types of data you have will dictate what type of shape you're going to use. And so I'm going to go through these kind of quickly, but I'm going to point you in a direction of some more documentation if you're interested in what other geoms are available. But say we're going back to our penguins data set and we're looking at species, the relationship between species and body mass. And say we want to use a box plot to do that. So what we can do is just do geom box plot, right? And so ggplot takes that data, uses geom box plot, and then outputs a box plot for us. And then we can see that there are differences across the different species in regards to body mass. Is it entomologist? No, entomologist is bugs. I can't remember. Yeah. So people that study different species and animals will probably be interested in this, but I don't think we need to talk about the differences between the different species of penguins. But if you're interested, there are groups of people that look at that. So let's just say we want to look at two categorical variables. Well, ggplot can do that. So instead of using geom box plot, or depending that we're using two categorical variables, we can use geom bar, right? But instead, in our aesthetic, what we have to do, because we have two categorical variables, we have to specify our x, and then we have to use this aesthetic called fill. And fill is what's going to put our species, or it's going to actually create that like stacked bar plot for us. And so you're going to see that on the y-axis that ggplot does the calculation for us. So it actually goes and actually makes the calculation. You can see the total for each species, but then you can kind of see a little bit about how much of each species are within each island. So just a stack bar plot, but big thing takeaway here is it's just a different aesthetic to get what you want, especially because we're using two categorical variables. If you want proportion rather than frequency, you can do that. You just have to use the same aesthetic mapping, but you just use this position equals fill. And now what you're getting is you're getting, rather than the straight frequency counts, you're getting the proportions, right? And so you can kind of see here on Bisco Island, the majority of penguin species that are on here is Gento, and you can kind of get a sense of it's about 75%, right? So just a small little changes the representation of our plot. So it's not only just our geom that can affect the shape of it, but it's also the parameters that we pass into the specific geoms. Two numerical variables, so scatter plots. ggplot is really great at doing this. All we have to do is just represent which numerical variables we want in our X and our Y, and then pass on geom point. And then you have your scatter plot. You have flipper length, millimeter on the X, body mass on the Y, and then you get the representation here using geom point. So pretty straightforward. I think scatter plots are one of the first kind of like data visualizations that you see in your stats courses, but ggplot can do it. Say you want to do 3 or more variables, you can absolutely do that. With this, it's the same thing, but we're just going to map on species and island onto our plot. And so what we can do is we can use other aesthetic mappings to map different variables. So say we want species to be a different color. What we can do is we can add species and then it changes the colors of the points. And in addition to that, if we also want to include the variable island, we can use shape, which is an island, right? And so you just pass island and shape. This is okay. This is a lot of information on one plot. So another representation of 3 or more variables is to use faceting or small multiples. So what we can do is we can actually split these out into separate mini plots, essentially, using facet wrap. And so basically we're going to use the same code here to get that representation of our scatter plot. But instead, what we're going to do is we're going to use facet wrap and we're going to split it up into small multiples into island. So I'll give a second, open it up for any questions here. I see a couple of people have some stuff in the chat, so I want to make sure I'm following along here. Ornithologist, thank you, Boulevard, appreciate that. I don't know all my sciences, so I lean on this group to help me out quite a bit. So Austin has a question. Does color always have to be in the aesthetic argument? I believe since it's outside sometimes, but I don't always know why. It does not, and we can pull this out and maybe play with it later. I obviously want to give Dewey enough time to talk about workflow, but you can use like a static color. So if you're interested in you're not interested in mapping the variables out of it, you can pass color outside of aesthetic to do like a static color. But if you do that, every color is going to be that static color, right? So if you wanted all points to be red, gray, whatever, or a hex value, you can do that. You just have to move this color parameter outside of geom, outside of the aesthetic mapping. Aesthetic basically is like saying, take this variable and map it onto that specific aesthetic, whether that be color, fill, shape, X, Y, whatever it may be. So
yeah,
go ahead, Dewey.
I was just going to say it may be obvious to everyone, but just perhaps worth saying that when you look at this statement, this ggplot statement, flipper length, body, whatever that is, body mass, species, island, all of those things are columns in the database, right? Essentially, it's a data frame that has columns, variables. Those are variable names or columns if you thought about it like a spreadsheet. I just want to make sure you knew that those weren't just pulled out of somewhere. It's directly related to whatever data you're passing in, and that's what the Penguins data looks like.
Yeah, absolutely. And I probably should have started from the beginning and gave us a little refresher that we're working with the Penguins data. I just wanted to get right back into it. But Dewey is exactly right. Like species is a variable in our data set. Island is a variable in our data set. Absolutely. So there was another question here. What's the difference between facet wrap and facet grid? I know the syntax is different. You can get the same like small multiples. I'm going to be honest. I just usually default to using facet wrap. But we can look at the documentation and we can kind of get a sense of what the difference is. So
I can answer that. Usually facet grid, you use 2 variables, one on the x-axis and one on the y-axis. By wrap, you basically say which columns you want to have plotted, wrapped around, but then it fills one row after the other. So it just wraps around. And so when the row is full, then it starts in a new line and plots the next plots. So the x and y axis doesn't tell you anything how stuff is plotted. While in the grid, you are explicit. One variable is along the x and faceted along the x, one along the y.
Yeah, excellent. Don't even need to pull up the documentation now. Stefan, right? Okay, cool. Thank you very much for adding into that. I really appreciate that. And then Bolivar added some additional context in the chat here with like facet grid. I usually default to facet wrap because I don't have to use some more of those kind of extra syntax to get those extra columns in there. But depending on your context, you might have to. So there is a difference, and you might want to check that out. So excellent, great. What other questions do people have before we move on to saving your plots or some common problems? Excellent, great. Just for the sake of time, I'm not going to go through these exercises. And in fact, we've talked about most of the things that are highlighted in here. There is one thing that I do want to discuss a little bit, or like something that I learned that I thought was kind of interesting, is the idea of the labeling or the actual like legends itself. I didn't know that you could make these the same, and all you have to do is just pass in your labs the shape here, and then it will actually just like combine these two into one. So I think this was a good reminder to me, even though that I've used R for several years, I could learn something new. And so this was something new that I learned that you could do, is that you could just have the same legend, but you just have to pass in labs species, and then it will just automatically combine it. So ggplot is definitely magic in some areas. I have to admit that there is some magic that happens with it. So again, you can kind of read through this. I'm just for the sake of time, I'm not going to go through every single exercise, but I thought that was kind of interesting, something that I learned that I wanted to highlight. All right, so we've done all this work. Say we want to save our plot. Well, ggplot has a function to do that. So if we want to save our plot, what we're just going to use is we're going to use ggsave. Now, what's nice about this is ggsave is convenient, because what it will do is it's smart enough to basically know that this was the last plot that we created. And so if we do this right after the plot, it will do our last plot. We don't have to pipe it. We don't have to use the plus. We can just do ggsave. If you want, you can save this, or you can assign a variable to this. So you could say like, create, do an assignment operator and do like flipper length, whatever name your variable, and then pass it into ggsave if you want to save like a specific object. So you have this convenience available to you through ggsave, but you don't have to. If you want to be very explicit on what you want to save, you can do that as well. You also have a lot of opportunity with different parameters or arguments of this function to describe the width, the height, what type of units you want to use for your size. I think you can do all kinds of stuff with ggsave. So if you have a very specific need for the detail of your plots, ggsave's got you. It's also good to set your width and your height to help reproducibility. Use that for however you need, but ggsave is really nice. The other thing, there's a discussion or a question about in the exercises about how you save different types of file types. You just have to change the file type here. Like if you need a PDF, .pdf. If you need a JPEG, .jpeg. All kinds of different things. Just read the documentation. Just use the file extension that you need for the actual output. And that was the question here that I was hired, So if you need PDF, JPEG, TIFF, PNG, whatever you need, more than likely ggsave can help you out. Okay. All right, so to wrap up here, there was one other slide that was added. This wasn't discussed in the chapter itself, but I think it's always good to talk about common problems, because if you're somebody that's new coming to this, more than likely, as you've been coding, you've come across problems. The big thing to know is that mistakes happen to everyone. And if many of you are familiar with Hadley Wickham, Hadley Wickham's like the most famous R user or R developer that's out there. If you've searched anything R, you've probably come across his name. Even Hadley himself makes mistakes. I don't know him personally, but I'm sure he would say that I do make mistakes myself. It's a common thing. It happens. So some things that you want to look at that you kind of just have to learn, that some of the common mistakes, like if you run into an error that you want to look for, is maybe you have mismatched parentheses or quotations. Maybe you have a plus in the wrong spot, right? Or maybe you just misspelled something. And so Allison Horst has some really good like cartoons and some art that she's been putting together. Basically, here's a cartoon describing a pretty common experience that everybody has in regards to naming something, right? Or having a misspelling. So there are some conveniences, or there's some like tooling out there that can help you avoid these or catch this. if you're working in RStudio to help you catch the like matching parentheses and the matching like quotations, there's this setting called rainbow parentheses that got rolled out in 1.4. It's just a setting that you can change, and I can put this in the chat for people to have it. But basically, it changes your RStudio so it has colors for all the different types of symbols that you have out there, and it helps you match it, right? So if you're doing some like really gnarly code here, it will actually color it to kind of help you see, am I actually matching my, my symbols that I need. In addition to that, RStudio also has on the side here, many of you probably seen it, like if you have a syntax error, it will be smart enough to give you some issues like if there's like an issue here. So like I'm trying to think of one here. How can I break this code? No, that won't work. Maybe I'm trying to break it, but many of you probably had that experience where like a red X will come in. Usually that's an indication that you have something wrong with your code. So if you see like a red X, you're more than likely going to need to address it. I'm not sure how to break this just yet, but I'm sure many of you've had that experience before where you've seen the red X before you run the code. That's a good indication that there's something wrong and that you need to look into it. So how do you solve those things? Basically go through debugging. Thank you for posting that stuff, and I really appreciate that. Read the error messages. Most of the tidyverse, they have a very heavy emphasis on making very clear error messages. So read them. They usually can give you a good sense of what's wrong. Google is your friend. There should be an addition to this, ChatGPT, or, well, I'm not endorsing any AI tool or specific AI tool, but use AI. It's great to plug the error in and ask it to see, because that may lead you down a path to solving your problem. Look at the documentation. Read the friendly docs. The docs are usually really good, especially within the tidyverse, to help you solve common problems. Ask your friends. And then the biggest thing is just don't give up. I mean, there's countless amounts of times that I've run into errors or issues, and then I have to figure it out. Maybe I have to walk away, come back at it, maybe come back at it tomorrow, and then it solves itself. And so sometimes you just need a break, but the biggest thing is just don't give up, because everybody makes mistakes, and you can solve your problems. I know everybody's capable of doing that. So, all right, cool. Well, I went over my goal of being done in 10 to 15 minutes, but that was our conversation about data visualization. I'll open it up for any questions or comments. I'll check the chat, but any questions, comments about this chapter? Thanks, Dewey, for posting how to get to the global options and doing that. All right, cool. Well, if there's no other questions, Dewey, I think you're up. So I'll stop sharing and then I'll let you take over.
All right, great. Well, thanks everybody. And just a quick background on me. I'm brand new to R. I picked up the book just a couple weeks ago, but I am in a data science master's program. So we're in week 2 and we've covered quite a bit of R. So we've certainly covered these basic concepts that I'm going to cover here in chapter 2. So it was good that I picked one that I had already covered. Although, it doesn't really matter because we're here just to go through it and learn together. So even I'm sure if there's something I say that isn't quite right, there's great minds on here that will help clarify things. So let me go ahead and share my screen. I'm going to mostly go with the slides as is, and then I'll just sort of highlight a few things within RStudio that I think sort of add a little bit to it. There's one slide in particular that's kind of an advanced topic that I was surprised was in there, but we'll talk about it very briefly. So in chapter 2, we started with chapter 1 of showing how to do visualizations, and in that you're using a tidyverse package, ggplot, and you're using a data frame, and you're using functions with multiple parameters and sort of chain together with the plus sign in this. These are actually pretty advanced topics from a programming standpoint, right? To actually know like why it's working that way. Anybody on the call that has done programming in other languages probably feels pretty comfortable with what they're looking at. But I know someone new to programming probably sees those ggplot statements and doesn't really know what the heck is why it works that way, right? And so I think one of the things that Workflow Basic does is try to get you established in some very basic low-level kind of programming concepts and how those programming concepts work in R. So I suspect that for people that are familiar in many languages, you already know how to create a variable and these kind of things, but we're gonna look at it just from a very basic standpoint. So again, we're gonna talk about some basic R coding, style conventions, importance of commenting your code, recognizing good practices, and then being able to call functions, and a little bit of word about what those functions look like and why we're calling them the way we do. Any questions before I jump in? And really feel free to, just like Colin, feel free to interrupt, feel free to add. I've done, even though I don't know R, I've done a lot of presentations in my day, so I generally don't follow a script, so you're not going to be disrupting me in any way. Just jump in, because I'd rather us chat about it rather than me doing all the talking at you. So the first thing is, R is a language that was designed for stats, right? Stats and probability. And so as you might imagine, it's really good at doing math. But I mean, all languages are pretty good at doing math when you look at these kind of basic things. But there are some pretty important difference that I want to highlight. So all we're showing here is that, you do 1 divided by 200 times 30 and you get 0.15, right? No big deal. Or these kind of pluses and divided and you get this. You can do things like sign, and you can use a predefined constant variable called pi. So it, which resolves to 3.14. So just basic math, right? One of the things that I'll highlight, and we'll talk about it a little bit, not in great depth, but a little bit in a later slide, is you notice when you see these outputs, it has this 1 bracket. That's because by default, everything parameter or every variables, all of the variables in R are vectors. And that's the case so that that's one of the things that makes R so good at doing stats, because things are represented as vectors. And so all of the vector math and the linear algebra that comes with advanced stats is so much easier to do in R than it is in other languages, because you don't have to, as I'll show in a minute, you don't have to iterate across elements in a matrix or in a vector. It does vector math auto-magically. But I just want to highlight, that's why you're seeing that 1 there. That's not a line number. That's not an output number. That's actually the index number of the vector. Any questions on that? Nope. All right. So let's talk about creating new objects or variables or things. You use an assignment operator, which is this less than dash. On just about every keyboard, I think it's Option dash. So you'll want to get pretty comfortable with that shortcut, because you'll use it all the time. Oh, they show it here. Sorry, I'm I'm riffing on stuff that I wasn't even sure that. Anyway, so Alt dash or Option dash for Windows versus Mac. And again, an assignment operator, the way you think about this is to say is assigned to or to be assigned to. Some people say gets, pretty straightforward. Again, if you're in programming, you have programming experience. If you have a line like this with this assignment operator, you're taking 3 times 4, and then you're assigning it to a variable named X. Nothing really earth-shattering there. If you run that, you'll see that and then to output X, you can just type X and that will output it. You don't actually have to type print or echo or any of these other kind of commands that you might know from other languages. You just type X and it'll output. And so what we did there is we did the math, we assigned it to the variable X, and then we output X. And again, you'll see that vector notation because everything's a vector. I will just point out that the assignment operator that you're used to in every other language, the equal sign, is perfectly valid. So you get the exact same answer. You can do the equal sign. My sense is that our programmers like the assignment operator, and there's some really subtle kind of esoteric cases where the assignment operator and the equal sign aren't technically identical, but for just about everything you're probably going to do over the next several years, they're identical. I don't know, Colin, you want to weigh in on that if those statements are right or not?
I mean, I'm sure there's some like underlying like bottom stuff like under the hood that are different. But yeah, I mean, the assignment operator is going to be your main tool for assigning variable names. There's like a little tidbit of why the assignment operator. Somebody has to confirm this because I think I came across this like a while ago because I was like, why do we have the arrow? Well, I think when they first were developing S, which is the precursor to R, they were working on computers that they actually had a physical arrow key. And so that's why the assignment operator, somebody's got to confirm it for me because I got to find it again. But I think that's why we have the assignment operators, because in S, the computers that they were using had a physical arrow that they hit. And that's how the assignment operator got added. So
I see.
I got to find that article somewhere, but that's the only thing I have to add.
Okay, no problem. So I thought I'd show at this point, taking a group of numbers and combining it. That's what that C stand for. That's a function. So if you can look up any function with, question, I think we showed this last time, question mark and the name of the function to get information in your help pane. So it's very useful to do. I do question mark function name all the time since I'm very new to it to figure out like what it works. But all this means is combine these 6 numbers and then put it into the variable R, right? Store it into the variable R. And like in another language, this might be how you create an array of numbers, right? Or a list of numbers. But it's still important to note that when you do that, it is a vector. In R, it's a vector. So it's not an array. It's not a list. It's technically a vector. So if I output that, it's showing vector of 1 row with these values, right? And then you can tell it's a vector and it does vector math, right? So if I do x plus 1, it's going to add 1 to each element of that vector. So you see what it did there? 1, 2, 3, 4, 5, 6. And then I did x plus 1, and it added 1 to 2, added 1 to 1, added 1 to 2, added 1 to 3. So that's vector math right there. Any other language, you can't take an array and add 1 to it. You'll get an error, right? You'd have to do some sort of array intersect function or push or pull, or every language describes it differently how you add elements to an array or a list. But this is dramatically different because it's a vector, and by default it does vector math. I might be getting ahead of a slide or two, but nonetheless. Any questions on that? No. Okay. With regard to this assignment operator, it can go the other way. So you can, instead of saying I'm going to define this variable x and then stuff something into it, you could do some operation and stuff that, go the other direction and stuff that into a variable, which is essentially what we do here. We take ggplot, which we just spent, Colin spent some time going over. We're going to do that, and the output of that, we're going to stuff into a variable called plot. You could have this on the other side. You could do it either way. Doesn't matter. And then you can output plot and get it this way. Yeah, go ahead.
So just a couple of things, and people could jump in because I don't want to dominate the conversation, obviously. But it's general convention not to do this, or this last example. You can, and it works, but just most of the R code that I've seen usually do it on the left.
Right. That's
kind of the big thing. And then the other thing that it's going to be tricky, and I don't know if we want to get into the weeds of it, but it's not that you're stuffing it into a variable. What actually is getting saved is the vector, and you're assigning a name. So I know it's like a really it's more of an advanced topic to talk about that, but like what's actually getting stored is those values and you're assigning a name to it. And that's one benefit that R has, is that because it's only storing. So if you have like multiple vectors that are the same, it's going to reference the same vector. So we don't need to get in the weeds of it, but it's one distinction that you kind of talk about, that when you do the assignment, you're not actually storing things into a variable, you're assigning a name to an object, which is maybe the vector. But I don't know if you need to know that if you're a beginner, but you will. I guess I am that person that just did the, well, actually. But
Yeah, and in other language, what Colin's saying, I think, and he can correct me if I'm wrong, is that this is creating an object in memory.
Yep.
And then we're storing a pointer to that object in memory. And so what you end up with, if you were to actually low level inspect plot, it would be a vector of length 1 with an object pointer. So that
I think so.
Yeah, it's kind of in the weeds, but it's useful to know. Yeah. Yeah.
I didn't want to be that person, but somebody was going to say it. So
no, it's all good.
It.
Yeah, it's all good. I mean, it's good. I'm sure that there's people on the call here that have programming experience. So this idea of, I think it's always helpful for me, at least, to be able to relate that to what I'm doing in my other languages, right? And so I think it's useful. All right. Yeah, and then this is the slide where I was like, oh, well, they're bringing up a kind of a much more advanced topic, but I suppose we could talk about the double assign. So I don't know if they brought this up in here just to make sure you don't make this typo, or I don't know. I'm not sure exactly why this is brought up at this point, but this is a different operator. It's called a double assign, and it behaves differently, and it has to do with object scope or function scope. So you could create a function like this called counter. So what we did is we created this function, we put it into the counter variable, right? Made counter become this function essentially. And then we create some stuff up here, and then we create a function within, and this is called an enclosure, but nonetheless, you create a function here that does something. And then you take, so here's how you would assign that counter, that variable that you just created, to that function that you just created. This is how you would assign it to a variable. And then you can call that with x parens, like this. And the key here, and I'll illustrate this, is when you run the x parens here, so when you run this, the assignment part of it, it's instantiation, if you will, of the function, it runs this part of the code, but it doesn't run this part of the code. And then when you run this, each time you run this, it runs this part of the code. Because of that assignment operator, that's saying take the result of x plus 1 and put it up here, whereas this just says put it, yeah, and I'll show you the difference here. I know this is a little, I don't know how much detail you want to go into this column, but so if you run this, you'll see you get a value of 1, right? And if you run just this line again, x function, you'll now see 2, and then you'll see 3, and then you'll see 4, right? But if I change this to a regular regular assignment, you need to clear your global environment or redo your function declaration, or you'll get mixed results there. But nonetheless, if I run this again, look at the difference. So we got 1 the first time, but now what do we get each time we run it? 1, 1, 1, 1, because it's going into this function. It's saying, I don't know x, because it hasn't been defined in the scope of this inner function. So it says 0 plus 1 essentially equals 1 each time. Whereas the first way we did it with the double assign operator, it says, oh, I know x because I have visibility out here. It's been defined to 0, and then I'm going to add to that x and store it up there in the scope outside of my enclosure, essentially. Or I don't know if I used exactly the right language, but I think I'm pretty close. But I think it's a much more advanced topic. I think we probably won't cover a lot of this in the first several chapters, but Colin, maybe you can comment.
I want to open it up to the group. Does
Okay.
anybody else have any other comments that they want to add or thoughts? Again, this is an advanced topic. I think we'll get to it when we start talking about functions, but I want to open it up for anybody else that wants to have any comments or questions.
I have a quick question. I was just curious if this is similar to using loops at all, if it's kind of a similar idea.
Well, loops are definitely a little bit different in that you can do sort of standard loops in it like you do in other languages without double assign or having to manage scope in this way, in quite this way. There might be some similarities if you have nested loops, but it sort of has to do with scoping. Yeah, I don't know.
Okay,
That may
that's
not have
fine.
been
That's
a
okay.
that may not have been a great answer, but
Hey, no worries. I appreciate it.
This seems like in Python, you would declare X to be non-local in the inner function to manage the scope. So this seems like that's what this is. That's kind of analogous to what this is doing.
yeah, feels like it to me. I think that sounds analogous to me. I learned about this operator when I prepared for this presentation because like we didn't like in my R class and in my degree, we didn't cover this operator yet. Cause again, it's an advanced thing that, so if I was brand new to R and you're just trying to learn R, I'd put this over on a shelf and not worry about it.
I'll be honest. It's good to know about it, but in the development that I've done, I've maybe only used it once. And so it's one of those things where it's like you can know about it, but it's just you got to be really careful with the scoping rules. You got to know what scope you're working in and how it works and how it affects the outside part of the scope that you're working in. And yeah, like Dewey said, put it on the shelf. If you need it, use it. If not, then you probably will use it sparingly.
Yeah. Okay. Well, I thought I'd talk just a couple, just a little bit more about vectors. This it wasn't technically in the slides, but it was something that we covered in my course that I thought was useful to talk about vectors. So again, what we're going to do here is, oh, maybe this is in the slide in some way. Let me see where we go. I should stick to, oh, yeah, it is. Great. So I'm not too far off. So just like I did above, we're going to take the combine function and take these prime numbers and put it into a variable. It gets stored as a vector. And then when you do math on it, just as I mentioned, just to reiterate, it does vector math. So it multiplied each element in this by 2. 2 times 2, 3 by 2, 5 by 2, 7. You can see what it did there. There's a concept called vector recycling that will become really important as well. And we don't mention recycling in the slides, but I think it's rather important. And it's the way the vector math works. So imagine we got this same vector here in primes, and we add a second vector that's 1, 2. How does this work? What the heck does this do? Right? And so let me run it and tell you what it's doing. So you get 3, 5, 6, 9, 12, 15. So what this does is it does 2 plus 1, 3 plus 2, and then it recycles the second vector and does 5 plus 1, 7 plus 2. And then it recycles the second vector and does 11 plus 1, 13 times 2. And it just does that until it's done. Right? And that not super intuitive to me, like coming from another language, that's the result I was going to get. But hey, we're talking about vector math here, and it's different. And just a oh, I did a period instead of a comma. Imagine that your second vector is 3, length 3. Same idea. It's going to do 2 plus 1, 3 plus 2, 5 plus 3. then it's going to recycle that vector, 7 plus 1, 11 plus 2, 13 plus 3. And the reason I'm show you that example is because I want to show you what happens if you do 4. Because here you don't have a multiple of this vector, right? This vector is 6 elements and this vector is 4 elements. So how do the recycling rules work on that? For me, it's anybody's guess. Well, it's logical, but so in this case, you're actually going to get a warning that is going to tell you, hey, your lengths don't match. Are you sure that's what you wanted to do? It's okay if that's what you wanted to do, but just want to make sure that's what you intended. Because it'd be a somewhat weird thing to do, like in practice, right? In theory, it's fine, but and so what it does is 2 plus 1, 3 plus 2, 5 plus 3, 7 plus 4. It recycles 11 plus 1, 13 plus 2, and now it runs out of the first vector, so it just stops. It doesn't do anything with the 3 and the 4, right? So this is why they're giving you a warning. They're like, it feels like a strange thing to do, but maybe you got a reason for it. Yeah. Any questions about that recycling? I just mentioned it because it's kind of a little nuance that it took me a minute to sort of appreciate. Okay, great. And something like this, as opposed to something like this is much more important for you to understand than this. Right? This isn't going to come up, but this is going to come up all the time. Like every time you work with data, this is going to come up. But this isn't going to come up. So that's why I spent some time on it. All right. Comments. So you use the pound sign to insert comments. Here we're just putting, again, people with programming experience know what the concept of what a comment is. This is a line of code that is not executed, so you can type whatever you want after the pound sign, and it doesn't get executed. It's just a comment in the code to tell you what your code's doing. Create a vector of 2 prime, multiply prime type 2. I'll mention that these 2 comments are bad comments, and we're going to talk about why those are bad comments. Because they don't add. Generally, you want your comments to add to the understanding of the code, and this doesn't add anything, right? Because yeah, we know we're creating a vector of primes here. Yeah, we know we're multiplying it by 2. You don't need a comment to tell you what this does, right? Unless, you know what I mean. This is for other developers, right? The comments are for other developers that read your code, right? And so presumably the other developers know that this is multiplying by 2. And so it's really important because it saves future you as well as collaborators time by knowing why you put the code together the way you did. And again, it should be the why and not the how or what. Because again, you start with sort of a basic assumption that the person reading your code knows the what. And if they don't understand that function you use, they're going to look up that function. So you don't have to explain how a function works unless you're doing some complicated implementation of it. Maybe you might, right? But it's really all about the why. So instead of saying change default value to 0.9, again, that'd be real obvious in the code that that's what you're doing. But you're saying, instead of that, you're saying, I'm increasing the smoothing parameter to better capture the trend in the data. That's an extremely helpful comment because it tells why you changed the default to 9.9. This is just sort of comments 101 for you programmers out there. These 2 slides are true in every single language that you come across. So there's nothing. One thing I'll mention here, which I just thought to mention that I hadn't before, is multi-line comments. There is no multi-line comment. It does not exist in R. So I can't, like in the language I use PHP among other things. But in PHP, I would do something like this, right? And I'd say, here's a comment. right? Here's a comment or whatever. And then all of these things would be commented out. So a quick way to do a multi-line comment and essentially block out some code. You cannot do that in R. There is no such thing as a multi-line comment. Every line of your comment has to have a pound. Every line of your comment has to have a pound. So it's important to remember that because that'll trip you up as another developer. So there are shortcuts. So like I can select this code and on Mac do Command-Shift-C, which will comment out each of those lines. And then I can reverse it just as easily with the same command. But that's not the same as a multi-line comment. Okay, so I think that's an important difference language-wise. Yeah. Stephen mentions that, or Stefan mentions that it's okay to comment your code with what and how as you're learning for yourself. And absolutely, it's the first time you learned a function, put that comment in there so you can read it to next, you say, oh, hey, back in book club chapter 3, we learned about this thing and you were following along with an R script that you save off so that you can come back to it. And you're putting a little comment in there that describes it. Perfect, right? So this comment about doing the why only is really more about like when you're presenting it back to an audience often, right? It's only, but it's never a bad thing to put in a why comment. That's always useful for you or collaborators. Yeah, Bolivar says he puts dates in his comments. I think that's good. Yeah, it can be pretty helpful. Yeah, exactly. Especially, I put things like this, like, yeah, I think this code's going to break in 2 years, and then a comment, and then when it breaks in 2 years, people can reach out to me and say, hey, Dewey, you said this was going to break in 2 years, and guess what? It broke. Yeah, so often when I'm programming on my other languages, we use a ticketing system that's unique to us, and I'll put the ticket number in there so that we can look that up and see what it was all about. That can be helpful. That makes it a little brittle in that, if we change our ticketing system, then you got a bunch of comments that reference your old ticketing system. But nonetheless, that's still, it can be a pretty useful practice, I think. Yeah, links that you got code, yeah, do that all the time. Answer that you get in Stack Overflow or ChatGPT or whatever. Yeah, absolutely. Perfect. All right. So let's talk about we got 11 minutes. Yeah, so let's talk about the variables that we're creating. Right now, I'm just creating like X, right? But names have to start with a letter, but they can contain letters, numbers, underscores, and periods. Or what all can they contain there? I don't know what all they could contain. Is that or just underscores and periods, right? That's what that's saying? Or I don't, yeah.
Yes.
Okay, I wasn't sure if I was misreading the the way that was highlighted. Yeah, so I would say most people do, numbers and or letters and underscore is the most common, which we'll talk about in just a second. Needing to put in other things is usually is a little less common. You can usually get away with. I tend to be a little wordy in my variable names, so that they have meaning, right? So that you can read them, and I don't worry about the fact that it might be kind of long. Now, of course, I try to avoid this is a variable that, that you have to spend all this time reading it, right? But nonetheless, I tend to err on the side of good descriptive variable names so that and by doing that, the code can document itself without comments, right? Yeah. Colin puts a good link there to why good comments. That's good. Or good why comments. So the book recommends snake case. Keep in mind that R is case sensitive. So, variable is not the same as variable. Those are two different variables. One's capital and one's lowercase. If you run, and let's output the lowercase one. If you run this. So I output it and it got 3, and then I tried to add to a capital one, and it said, hey, that capital one doesn't exist. Right? But if it did exist, it would be distinct. So I wouldn't recommend having variables that are named the same except for a capitalization, unless you want to confuse the heck out of future you and other people that are using it, right? And not to mention, I just even made it more confusing because I made them have the same exact result. So you get the idea, though. That's a better example. 3 and 2, they're distinct. Case sensitive. Probably a little bit too much hammering on that. So this is kind of a funny slide that talks about different cases. They recommend snake case name underscore. So that's that's always been my go-to anyway. Some people, I'd say the most common I see are snake case, camel case is really common in the coding industry. I don't think you don't too often see Pascal case. Pascal case is really no different than camel case, except you capitalize the first letter. I think. But I don't think people ever. I haven't ever really seen that. Skewer case. Yeah, I think I'm not sure. Most languages won't like that because you know that's a operator, right? The negative sign or the hyphen is an operator, so it's not going to interpret that's going to interpret this as, most languages are going to say that this means skewer minus case, not of a variable called skewer case, right? So that's a no-no. Yeah, I don't know why you would do uppercase. I probably wouldn't do that one. Yeah, no case. Anyway, you can see these others. You can do this, but maybe why? Maybe ask yourself why. This is just a funny slide. They're just trying to be funny. But any questions on case? Oh, Daniel used Pascal, huh? Yeah. I mean, every once in a while, you know, I use a combination of snake and camel, and every once in a while I'll capitalize the first thing just because maybe it looks funny with it not capitalized, or I want to emphasize something about that variable, but most often I go with camel.
I'm going to jump in with a 5-minute call. So I think we could probably cover maybe one more slide. I do want to add to this Pascal case and snake case is just like pick one and go with it and follow the general conventions of the people that you're working with. And then there is some minor differences where I see Pascal case get used if you're doing some OOP stuff with like R6. You'll see Pascal case for some of that, but that's an advanced topic, but you will see it if you on your journey somewhere. So but yeah, let's do one more slide here and then we can wrap up for the day.
Okay. Yeah. I think we don't have too much left. Oh, maybe we do. I was sort of getting chatty. So functions. So overall functions look like this, right? And this is an example of the ggplot stuff that Colin was doing last week, or this week and last. And basically there's an argument, a value, and these are always displayed in the environment tab. So you can see all this stuff that I was doing with variables and primes. There's my environment tab. You see, as soon as I declare them, they're sitting up there and I can use them now, right? And inspect them up here. And often you'll want to clear this if you're doing multiple things, because this can confuse you if you're just sort of playing around with stuff, and clearing those is really easy with this little broom. So that broom's your friend if you're just sort of playing around and you don't want to confuse yourself. So I think some important parts of this is probably the most important slide on functions, right? Do we have time? Yeah, we got a few minutes. So it has to do with the ordering of it and whether or not you name your function, whether or not you name your parameters. So in general, you can name your parameters with like from equals, to equals in this seek case. And when you name them like this and reference them this way, the order does not matter. So you can do from equals 1, 2 equals 10, or 10, 2 equals, you can see that you can do these in any order. If you don't name them and call them this way, and you just say 1 comma 10, they do have a specific order. And that's by the definition of the function. So you cannot do, while these are all the same, this is not the same. And again, that's all has to do with how the function is defined. If you look at, it tells you that from is first. By default, it says from is first, to is second. And so by default, if you don't specify the order that you want, it's going to use that from is first, to is second. There's a little bit more to say about it, but let me see if we, oh, this is just, oh yeah, there's nothing really except exercises. So I think that's really the content-wise, Colin, what I wanted to cover. I don't think, because the exercises are sort of really simple typo things that you guys can do on your own. I don't think there'd be much value in doing, because it's just typos, forgetting
Yeah.
commas and this kind of stuff. Yeah.
A lesson
Right.
of having a keen eye to make sure that you have a keen eye and make sure that you train your eye to look for some of those common things.
Yeah.
So, Dewey, I really appreciate you covering. I think you covered some really great stuff today, and I think we got through the entire chapter. Like Dewey said, many of you can look through the RStudio features. I'm sure we'll come across them again. So, with the minute that I have left, we have next week is going to be data transformation. I have Austin listed here. So Austin, if you need any help, let me know, or if something's changed and you can't, let me know. We can figure that out. I can hang out here a little bit more past the hour, maybe just like 5-10 more minutes if people have additional questions. But I'm just going to open it up. If people got to go, have a good rest of your week. If not, I can hang out for a little bit. We can chat. But yeah, so let's just open it up for any questions, comments that people have from today.
Yeah, Colin, one thing I was going to say about this function is, one thing this doesn't talk about is default or required non-named parameters. That's kind of an important concept to understand with this as well.
Mm-hmm.
And I can just show a real quick example. If you look at median, for example, this is a function that calculates the median. If you look at the help on that, you'll notice that the first variable is shown here and it doesn't have a default. So you always have to include a number, you always have to include something there, and you don't ever reference it as a name equals, because the name equals doesn't start until your optional parameters.
Yep.
So it's an important thing, right?
Yeah,
I
that's
don't know
super
if that made
important.
sense. Yeah.
No, that's super important. Like there are some, and that's a decision that the designer will make, is like, if it's required, it won't have a default value. And so then it will push an error, and it will basically say like, hey, X is not defined or something. I can't remember the exact error. I've come across it plenty of times, but
Yeah.
The other thing that's
but you
really,
can still
go ahead.
sorry, you
Stephanie,
can
go
still
ahead.
refer, you can still refer to it though. You can say X equals, you can do it,
Oh,
right?
okay.
And
Yeah.
then
Yeah. Okay. Great. Yeah.
you are
Thanks.
allowed to. And this is also an excellent point. I totally forgot about this. It can be overwhelming with some functions because they have so many possible parameters.
Yeah.
And then just looking, when you look at the help and just looking at all the ones that have defaults, often you can ignore them when you start out. They might be relevant to you later, but for you to get a feel for a function, that's often a good entry point, just to look at those that are not, don't have defaults.
Right. Yeah. That's a good point. Yeah. Yeah. Sorry. I definitely botched that. You're right. You can reference that as X equals. Yeah. Yep.
I know there's some people coming from other languages too. One of the weird quirkiness too is that the function arguments, they will do partial matching. It will do partial matching. So if you did seek, I think if you did FRO equals 1, it will do a partial match. So that's one of the quirkinesses of arguments that R has that some people are kind of like frustrated with. I don't know why you would do that, but you can. So, what other questions do people have? Other questions, comments? Well, excellent. Well, if nobody else has any other questions, I'm going to jump off. Really appreciate everybody joining in. Hopefully, I can see everybody next week. Austin, if Austin's still on the call, if you need any help or you want me to help you with anything, I can stay here for a little bit. If not, we'll see everybody next week.